All right. So the last lesson we talked about in 4.2 was adding and subtracting polynomials. And all that basically encircled or consisted of was just finding out what the like terms were and then either adding or subtracting those like terms. All right. And if you recall, a like term is a piece of a polynomial or the term of a polynomial that has the same variable and the same exponent. They can have a different number, different coefficient, the number in front of the variable, but they had to have the same variable and the same exponent. And all we did was combine all the same variables and same exponents and shortened it. All right. What we're going to do today is reuse some of our knowledge from 4.1 in dealing with properties of exponents, and now we're going to learn how to multiply polynomials. Okay, so we're still continuing with our essential question on how are basic operations used in simplifying polynomials. Like I previously said, last lesson we dealt with adding and subtracting. Now we're going to focus on multiplying. And the learning objective that we're going to focus on is I can multiply polynomials. So that is all we are focusing on in this lesson is multiplying polynomials and the steps it takes to simplify them into our expression. Okay. So when you're multiplying polynomials, you must multiply each term in the first polynomial with each term in the second. Okay. So we have the first term right there. What we're going to do is using the distributive property and some previous knowledge of properties of exponents, we're going to multiply the first term with everything in the second term. All right. So we're going to do 4x times 2x squared. Then we're going to do 4x times negative 4x. Then we'll do 4x times negative 5. Now, in a rare circumstance, if there are three polynomials, all right, you got three polynomials that you're multiplying, multiply the first two, then use that new one to multiply the third. All right, you rarely come across that. Most of the time, it's just going to be a two polynomials multiplying one another. All right, it could be like C, where you have one term multiplying into a three term, or it can be like D, where you have a two term multiplying into a three term. You may also have a three term multiplying a three term. Okay, so let's take a look at C real quick. All right, so taking a look at C. So our using what we just talked about, we are going to multiply the first term with everything in the second term. Okay. Now, what that consists of is you multiply the coefficients, all right, and then you simply add the exponents together, and that's your answer. All right. So 4x times 2x squared. All right. If you multiply 4 and 2, that will give you 8. And then, just like I said, for the exponents, all right, for the variables, you're simply just, if it's the same variable, you will add the exponents. If it's two different variables, like if we had an x and a y, you would just put them next to each other. All right. But since 4x and 2x squared are a common variable, you're just going to add the exponents together, which is utilizing our knowledge of multiplication of like bases. Or in this case, we really don't have like bases, or we don't have a like number, but we have a like base. All right. So 4x times 2x squared gives us 8x to the third. Okay. Now that's done. He's over with. I'm going to mark him out so I don't have to sit there and think about it anymore. All right. Now we're going to do 4x times negative 4x. All right, before we even deal with the variable, I'm just going to multiply the coefficients, multiply the numbers that are attached to the variable, which in this case is a 4 and a negative 4. All right, so 4 times negative 4 gives us negative 16. Okay, now, same thing like we did with the first term, we're going to multiply x and x. Now, if you recall, if there's no exponent in the top right corner of a variable, you pretend there's a 1 right there. Okay, you pretend there's a 1. So in this case, it'll be 1 plus 1 or x squared. Okay, now he's done, over with, don't want to worry about him anymore. The last one, okay, the very last one is going to be 4x times 5. Same thing we did with the first two. We're just going to multiply the coefficients first. And then since 5 is just a constant, a number without a variable, we're just going to slap an x on it and call it good. All right. So 4 times 5 gives us a plus 20. And then like I said, we're going to slap an x on it. So 4x times 2x squared times negative 4x times 5 leaves us 8x to the third minus 16x squared plus 20x. Okay. Now, let's take a look at D. D is going to be a little bit longer just because we're multiplying a binomial, a two-term polynomial with a trinomial, a three-term polynomial. Okay. But we're going to use the same steps that we used for C. Okay. We're going to do 2x times 2x squared times negative 4x times 5, and then we're going to turn around and do 1 times 2x squared times negative 4x times 5. Okay, that's all we're going to do. So first things first, we're going to do 2x times 2x squared. All right, remember, multiply the coefficients first, then deal with the variables. Multiply the coefficient first, then deal with the variables. Okay, so coefficient first, 2 and 2 gives us 4. Okay, and then we multiply the variables, which in this case is x to the first and x to the second, which leaves us x to the third. Next things up is 2x times negative 4x. Multiply the coefficients, 2 times negative 4, which leaves us minus 8. Then add the variables together, which in this case is x to the first and x to the first, which gives us x to the second, or x squared. Then we're going to do 2x times 5. Because 5 is a constant, all we're going to do is slap on that variable right there. So 2 times 5 is 10. And we do that. Like I said, add the x. Now, that is distributing 2x to everything in the second polynomial. All right. Now we're going to distribute 1 to everything in the second polynomial. Now, basic multiplication. All right. 1, if you multiplied 1 and a number and the number, like 2 times 1, 3 times 1, it was always that number. All right. Same thing with polynomials. So instead of just simply restating everything, we're just going to rewrite 2x squared minus 4x times 5 because it's all going to be the same thing anyway. Because we're multiplying by 1. Okay. Now, if you sit there and look at this, this looks very similar to adding and subtracting polynomials because it is. All right. Now what we've got to do is we have to simplify and combine like terms to get the shortest expression that we possibly can. Okay. So looking through here, I'm going to use the shape strategy. All right. So that way I can get an idea of what terms we have. So I'm going to put a square around all the cubes. He's the only one. I'm going to put a circle around all the squares. There's 2. I'm going to put a triangle over all the x to the first. There's 2. And I'm going to put a diamond around all the constants. In this case, there's 1. All right. So now we're going to combine like terms. So there's only 1 square. So we're going to rewrite him 4x cubed. Now there's 2 circles. All right. -8 plus 2. All right. So we're just going to add the coefficients. So -8 plus 2 gives us a -6. And then we're going to attach x squared to it. Now we're going to look at the triangles. All right, all the x's to the first. 10 plus -4 gives us a +6. Then we're going to add the variable, and then poor little constant +5 is all by himself. So we are going to do that. So 2x plus 1 times 2x squared minus 4x plus 5 gives us, all right, 4x cubed minus 6x squared plus 6x plus 5. Okay, so let's take a look at a couple more examples. All right, we're going to take a look at a couple more examples, and then we're going to look at how this could be applied in a real life situation. Okay. So, first things first, we're going to multiply -3x to x squared minus 3x plus 4. Okay. So, -3x times x squared, that, remember, if there's not a coefficient, that's an understood 1. So it's -3x times 1, or just -3. Then you're going to add the variables together, or add the exponents. So x to the first times x to the second gives us x to the third. Now we're going to do -3x times -3x. All right. -3 times -3 gives us a +9. And then x times x, or x to the first times x to the first, gives us x squared. -3x times +4. -3 times +4 gives us a -12. And then we are going to slap x on it. So -3x times x squared minus 3x plus 4 equals -3x cubed plus 9x squared minus 12x. Okay. Next one up. 2x minus 5 times 2x squared plus 3x minus 1. All right. Remember, we're going to distribute the first term in the first polynomial. Then we're going to turn around and do the same thing with the second term. All right. Then we will combine like terms, and that will be our answer. So, first things first, 2x times 2x squared. Multiply the coefficients. 2 times 2 gives us 4. Then we're going to do x times x squared, or x to the first times x squared, which gives us x cubed. So 2x times 2x squared is 4x cubed. Then we're going to do 2x times 3x. All right, 2 times 3 gives us 6. X to the first times x to the first gives us x squared. Then we're going to do 2x times -1. All right, because it's -1, we're just going to rewrite 2x, or minus 2x. Okay. Now we're going to multiply -5 through with everything in the second one. All right. So -5 times 2x squared. All right. -5 times 2 gives us -10. Then x squared, because -5 is a constant, does not have a variable. So we can just attach the variable it's multiplying with. Now we're going to do -5 times 3x. -5 times 3 gives us -15, and we slap an x on it, because that's what was with 3. And -5 doesn't have 1. And now we're going to do -5 times -1. All right. Negative times negative is a positive. 5 times 1 gives us 5. Now, using the shape strategy, I mean, you don't have to do the shape strategy. You can just line up top to bottom the variables and do it that way. All right. Whichever one fits you best. I'm going to use the shape strategy because I like that. I personally like that one better. So 4x cubed, there's only one x cubed. We're going to look at all the x squareds. There's an x squared. There's an x squared. That's it. Now we're going to look at all the x to the first. There's one. There's one. There's no more. We're going to look at all the constants. There's only one. He gets a little diamond. Now we're going to add all the same shapes. Looking left to right, there's only one square. He gets to be rewritten. Looking at all the circles, plus 6x squared minus 10x squared. Positive 6 minus 10, that gives us a -4. We just reattach what common variable and exponent they had. Now -2x plus -15x, that gives us a -17. And then their variable was just x. And then since there's only one diamond, one constant, we rewrite him. Okay. And that is our answer. So 2x minus 5 times 2x squared plus 3x minus 1 results in 4x cubed minus 4x squared minus 17x plus 5. Okay. Now, we're going to take a look at this one. Okay. So we're going to pretend for whatever reason our measurements got screwed up, or we're going to see how we can adjust different measurements for what. Okay. So a box is created from a sheet of cardboard 20 inches on a side by cutting a square from each corner and folding up the sides, which in this case is figures 4-3 and 4-4. This is 4-3. This is 4-4. We're going to let x represent the length of the sides removed from each corner. All right. So we are going to write a function v. All right. So our answer is going to be v that represents the volume of the box in terms of x. Okay. So taking a look at this, we're going to create an expression and then we're going to solve it. All right. So for a, so if you recall, v or volume is length times width times height. Okay. Now, our length and our width, okay, this is our length or width, and this is the other. And this is our height. That's the height of the box. So length, width, height. So we're going to substitute each one into the function. Oop. Okay. So in place of L, I'm going to write 20 minus 2x. In place of w, 20 minus 2x. In place of h, I'm going to write x. Okay? Now, using our multiplying polynomials, we're going to multiply the first polynomial with the second polynomial. So 20 times 20, 20 times negative 2, then negative 2 times 20, and then negative 2 times negative 2x. All right. And then we'll turn around and multiply all of those with the x. All right. So technically, this is a 3-piece polynomial. All right. We have 2 binomials and a monomial. All right. We have a 2 terms. We have 2 terms, 2 terms, 1 term. Okay. So 20 times 20 gives us 400. 20 times negative 2 gives us minus 40x. Now we're going to do the same thing. Negative 2x times 20, that gives us a minus 40x. Then negative 2x times negative 2x gives us a positive 4x squared. Okay. Now we're going to combine like terms real quick. So 400, our like terms are negative 40x minus 40x, which is also minus 80x plus 4x squared. Now we're going to multiply all that by x, by this one right there. So I'm going to drag them down. Now we're going to distribute the x amongst everyone. All right. So x times 400, 400x. X minus 80x is minus 80x squared. X times 4x squared plus 4x cubed. So this is our function. That is it. That answers A. That is our function. That is our equation. Now what we've got to do is find the volume if a 4-inch squared is removed. All we have to do is substitute 4 for x. So instead of x, we'll have a 4. Instead of x, we'll have a 4. Instead of x, we'll have a 4. And if you punch 400 times 4 minus 80 times 4 squared plus 4 times 4 cubed, that will give you 576. All right. And because we are dealing with volume and inches, our unit of measurement is inches, and since it's volume, we got to do inches cubed. Okay, so that is it for multiplying polynomials. We will see you for lesson 5.